Hi all. So do you remember how last time we dunked pretty hard on Yang and we compared what it takes to do this full model-driven network automation when you don't have Yang, when you have an open API specification where you can generate Pydantic classes and kind of get this full model-driven experience without going through the pains of Yang. Now, we did it, of course, with a reason, right? We suffered from dealing with Yang and we knew the tooling was not as good as we wanted it to be. And it may have come across as we were whining and kind of trying to solve the problem with the tools that we have without really investing in the tools. And I think that's a common sense or a common sentiment with Yang tooling is that there is not enough of adoption of this Yang based model driven automation because the tooling is not there. But at the same time, the tooling is not there because there is not enough adoption. So it's kind of a chicken and an egg problem. So once we did that, and I showed an example how we can automate stuff really efficiently with Nokia, IDA, and our Open API spec, it kind of steered a lot of discussions in LinkedIn and then in Network Automation Forum Slack channel. And then the good thing is that out of this discussion, we wanted to kind of fix things instead of just saying, yeah, the tooling is not there, full stop. Maybe there was something that we could have done. And I'm so grateful to two of my peers and kind of colleagues who are not employed by Nokia, by the way, Urs Baumann and then Peachey, who kind of stepped in and said, like we can do something about it and let's try to do something about it. So it's been only less than 2 weeks and we've come up with a pretty nice prototype that, of course, it was not just the work of 2 weeks. The project that we have been using and that I will demonstrate today has been around for a year. It's just like it didn't have enough love, I would say. And I think what we tried to do is we tried to give this project a bit of laugh. Now, let me tell you what I'm talking about. So before we start talking about the practical implementation, let's take a step back and see what it takes to automate a network from, 10K foot view. If you use a network management system like IDA or any other system, you typically interact with a system API. You don't talk to the network nodes directly. And that is where the kind of the simplification and the user experience come from. The hard parts, the nitty-gritty details are abstracted by the network management system. But when you do your traditional network automation, you typically have your automation client, can be your laptop, can be a system that you use to run your scripts from, can be a Kubernetes cluster with pods that are doing this pick up jobs and configure the stuff on your nodes. But at the end of the day, the automation client talks directly to the nodes instead of to an API of the network management system. And that is where the difference come from. When you use your automation client in this traditional network automation setting, what you typically do is that you use the payloads and the network management interfaces that your nodes expose. It can be SSH and screen scraping. Everybody did that, like no judgment, but it's probably the worst of them all. You can have a REST or RESTconf interface on your network nodes, and then your payload, typically a JSON payload because you use HTTP and JSON is kind of keen there. Or you might use netconf and then your payload is XML and you do your, edit configs, get configs, this kind of RPC operations. Or you might be living on the bright edge and use GNMI with, again, different kind of payloads encoded in Proto. So at the end of the day, what you are doing is that you're leveraging the interfaces that are exposed by your network elements. As more advanced your network elements are, the more probably progressive and network automation friendly interfaces you get. But at the same time, even if we take the interfaces kind of on the side, what you really do as a network automation engineer, you're crafting the payloads that configure your VLANs, NTPs, interfaces on your systems. Besides the interface itself, you need to create these payloads. It can be an imperative list of CLI commands, conft, interface, VLAN, blah, blah, blah. Again, something that is discouraged. And the reasons are probably have been discussed already a lot of the times from different stages, from different conferences. The imperative commands that are not typed are basically a quick and easy win for network automation. But as deeper as you go into the network automation, as more complex your automation becomes, the easier it is to find gaps in this solution and the harder it is to fix things in that solution. If you use JSON and XML, you again, the question becomes like, how do you create those payloads? And again, the quick win is do templating, change a templating, go templating, you name it. If you template a structured data, that is already a smell. You don't have to generate or template a structured data. Structured data means to be serialized from an object. And that is what we're trying to do here with model-driven approach. Instead of making you write those hairy Jinja templates where there is no there is no type validation, there is no syntax highlighting from the IDE, there is no way for you to verify the payload before you push it to the node. All of these all of these downsides of templating are very well known for anyone who dealt with network automation and templating. At the same time, as I said, it is a quick win. You can craft your Jinja template really fast and easy. It is intuitive how to create them. You just grab your output of the CLI with your payload and you just do your ranges and templating and Jinja filters, and off you go. But as I said, the problem comes when there are more sophisticated templating needs to be done to create those different things in your network operating system with maybe interdependencies between the elements. And then your template becomes kind of a proper programming language, which you don't want it to be. It meant to be simple and easy to read. And most of the templates are not. So yeah, I will not dunk on templating here because I think everyone needs to go there to understand the pitfalls of that. If you don't feel that there is a problem with your templating, then probably you're fine. Then maybe your automation is already kind of created in a way that you don't have these complex use cases where templating bites you in the ass. So we will talk about the different approach here. We will talk about this programmable approach where you deal with your objects in your native language. And in this particular video, we will talk about Python. Again, just because this is the most popular programming language in the network automation domain. We will talk about a particular project that has been created by Urs Baumann and his colleagues in one of the universities in Switzerland, which is called Pydantify. Now, in the previous video, we talked about Pydantic and how Pydantic and data model code generation projects, when combined together, can take an OpenAPI spec and generate Pydantic classes, which then you can use to create those nitty-gritty models and serialize them to JSON. The problem was that the Pydantic and data model code gen, they kind of ingested the OpenAPI spec. Now, your network operating system does not come with an OpenAPI specification. What it comes with is a set of Yang models. Now, with Yang models, how do you get those Yang models and generate code bindings? Again, this is not something that is new under the moon. We have had projects like YGOT, we have had PyYangBind, we have YangSon. There are a bunch of projects that already tried to a certain degree successfully to generate the code bindings for different languages in the past. The problem was that the PyYangBind was for quite a long while more or less unmaintained. Now, I think the previous maintainer made a point that it is now maintained. But when we tried PyYangBind with a set of non-open config models, it was not working. There were errors, and of course, these errors need to be fixed. But then PyYangBind generates classes for Python, and they generate it in a certain way. And we wanted to make sure that we can use the Pydantic project, which is kind of a leading project to generate, base classes for type validation, and it's a very well known and kind of popular way to create those type classes for your Python projects. So instead of using something that is again specific to networking, I think the idea of Pydantify was to take the same principles that software engineers use for non-networking projects, being Pydantic and data model code gen, and with them generate the classes for your network operating systems. And that is exactly what Urs Baumann and his colleagues did back in the day when Pydantic version 0.1 was released. But again, when you start a project and there is not enough adoption, it's easy to lose interest in it. And it's something that open source can suffer from quite a while. And Pydantify was not really working with, for example, Nokia's for Linux models. There were issues. But then we wanted to make sure that we can probably fix them. And that is what we did in the past couple of weeks. Now, as I said, the pipeline of Pydantify works in a way that you supply your Yang models that you can download from a vendor GitHub location or maybe from the general Yang repository where all vendors push their models. And then you tell Pydantify to take in those models. And as a result, Pydantify will generate the Pydantic classes that you can use with your network operating system and try to serialize the models in different formats. So I will show you what we did with Urs and Dan Peachey over the past couple of weeks based on the example of Astro Linux models. So I think what I wanted to do is to ensure that it not only works with OpenConfig models, not only works with basic examples like, simple models, but a full-blown set of Yang models that we at Nokia Astro Linux ship to our customers. And I think that what makes it a lot more interesting because that is like the proper full scoped model set that we wanted to make sure will work with Pydantify. So let's see how it works. So here is a repository that I called Pydantic as for Linux. In this repository, we provide the generated Pydantic models for Nokia for Linux. Currently, it's an experiment, so it's just the latest 24.10.1 release. But the goal is for people to simply import the package in their Python program. And using this import, they should be able to generate everything on the network operating system. So with Pydantify, you can, of course, take in the Yang models and manually generate the classes. But I think what makes the user experience way more compelling and easy is that if a vendor, in our case, Nokia Sol Linux, provide you a package that you can just import. So you don't even need to know where the Yang models are, how to download them, how to generate the models. So we, Urs, Dan, and I, we took the Astro Linux models. I created this repo, so I generated all of the top level models of Astro Linux, and we created those Pydantic classes for them, so that now you can import the project um, and start creating those automation using the fully native Python constructs instead of just dealing with typical Jinja templating. Now, how do you use that? Initially, I thought I would just show you some set of examples, pre-cooked ones, but I think it makes sense to show you how it works from the ground up, because a lot of people are really they were complaining that there were not enough examples how to start really using any of this Yang-based automation. And I totally get it. If you never dealt with Yang, it might be so confusing and you don't even know where to start. The tools emit errors that you do not understand. That is why let's do this from the ground up. Let's imagine that you have an empty project and you want to start creating those constructs with Pydantic as Linux project that we just open sourced, and see what it gets us and how to start. Okay, so here we are in an empty project where I have some custom module to set up login. So there is nothing to do with Pydantic now or SO Linux. I just have a bare project. And if we look at the PyProject TOML file, you see that I have just a few dependencies for linting, and I have the HTTP client here, and I also have the reach and rough installed. If you want to replicate the same example, I will show you the exactly same steps that you need to do. So let's first start an SR Linux container so that we will have a system to work against. To create a basic SR Linux container on your system, you can just type sudo container lab deploy and then point to an HTTP location of a single node lab. So slinux.dev/clabsrl is an HTTP location of the clab file that has just one node of the latest release. So when I run this command, I will create a topology of just one node, and that is exactly what we need. We just want to have a network operating system on our machine so that we can validate that we can generate different configuration items with Pydantic models, and that we can ship them or push them to the node, and node needs to accept it. So now my lab is running, so I can just type SSH SRL and I will be in my newly deployed network operating system. Okay, so we're back at our code editor. So what we need to do first is that we need to install this Pydantic Linux module, because that is where all of the models have been pre-generated by me so that you can use it in your automation scenarios. So if I open my terminal and I just say uv add, and of course you can use pip install. I just think uv is way better. So I can say git plus https, and then it's gonna be github.com srl labs Pydantic Linux. So we are installing a module, Python module from GitHub, and UV will do this really quick and fast. So now I have my Pydantic Linux installed, and there's of course a bunch of dependencies that are coming from Pydantify and Pydantic. So now it's all kind of resolved and good. Now, after we installed Pydantic Linux module, we can import things from it. And what is in this project is the generated Pydantic classes generated from Yang. So we can say import, if I can type, Pydantic Linux models interfaces as SRL if, for example. That will be our shorthand for the interfaces. And once we imported the interfaces model, we can access everything there is under the interfaces. Now, if you look at the set of models that we are generating for Linux, and I will just show you the repository that we have. In the repository, we have all the top level modules. Now, ACL, BFD, interfaces, network instances. And now you might wonder why. Now, these are the top level modules. And what top level modules mean is that they are sitting right next under the root. If you go to the Linux Yang browser and you open up a tree representation of our Yang, you will see that these are the top level modules. These are the ACL, BFD, interface, etc., etc. And we generate these models for you, meaning that you can create everything under the root, which means the full configuration tree is available to you for generation. Now, let's go back to the code editor. Once we imported the interfaces model, we can start creating the interfaces. Now, let's imagine that we want to create an interface Ethernet 1.1, and we want to create a VLAN there. We want to create a sub-interface in a Linux construct and add a VLAN tag there. So how do we do that? Like, that's probably the biggest question. If you never was exposed to Nokia Linux, you don't really know where things are. And Linux Yang browser that we just looked at is one way to understand the underlying models and how things are nested under each other and what are the hierarchy between them. So what we can do is that we can say, I will create an E11 object. This object will be from SRL if module. And as you can see, after I tap the dot, there is an IDE completion or auto suggestion that shows me what elements can I access under the interfaces model that we just imported. And here, if you type model, that will be your top level model for this interfaces construct. Now, again, I can do command click and I will open the model class that Pydantify generated from Yang, and here we can see the description that has been populated from our models. They are there as well. So now we can see that in the model there are different fields that you can access, or in the variables of this class. So there is an interface field, and it is an optional list of interface list entry. Now, what does it mean? If you tie it up back to the Yang browser, you will see that this is actually what interface is. An interface is a list, and it means that under the slash interface, you populate your interfaces. So in Yang, a list is actually a map or a dictionary in Python. They make it a little bit of a mess or confusion, but a Yang list is a map. So you need to provide a key, and your key will refer to an element of this map, and an element of the map is an actual interface. Besides this, if you go back to your IDE, you will see that you can enter or command click on the interface list entry, and this class will define the interface list entry, what interface can have under its name. There is different fields that you can supply to it. Of course, an interface might have a description, and the comments here will be generated or populated from Yang, so you will see exactly what the description means. There's also admin state. There's different many things. Now, we don't want to create a list of interfaces. All we need to create is an interface, a single interface. We want to create an interface Ethernet 1.1, so we don't need to create the top level model and then a list of interfaces. We just need to create single interface. So how do we do that? In our case, we need to create an interface list entry, something that we just browsed in the model. So if I type interface list entry, you see that there is a clause that is suggested to me. So I can just type enter and it will be auto-completed. And this interface list entry, the IDE shows me how many fields and what fields it has. So it has the name, there is a description, there is an admin state, everything that an interface has. Now, you might want not to just, go with command click and explore the fields here if you don't want to. We wanted to simplify that, and we created a JSON schema for all of the top level models. So if you go back to Pydantic Astro Linux browser repository, you will see that we specify which models we generate, and we also have the schema URL for each one of them. So if I click on the interfaces schema URL, it will open a schema representation of this particular module, which is an interface. And here you see that the root has an interface field, and this field is of type interface list entry. This is exactly what we're trying to create. We're trying to create an interface list entry. And if we go and click here, we see what interface list entry class comprised of, which fields it has. So it has a name, description, admin state. We will use all that. But this is a nice representation of the kind of the nesting structure of interfaces and interface properties. And then we will create a VLAN and you will see how it works. So going back, we are trying to create an interface list entry. Now, what do we need to do here? We need to provide a name, right? There is a name of the interface. If I click command control space, I see all the variables of this object that I can provide, and name is one of them. So if I do autocomplete to the name, there is a description of this field, again, coming from Yang, generated by Pydantify. Many tools have been involved to create all that, like data model CodeGen and PyYang. And here we see that there is some description that helps us to understand how to create a name. I know by heart that the name can be Ethernet 1.1, and that is great, because if I also click on the interface list entry, the name shows me that it's either none or string. So I provided a string value, so some type validation here for me as well. I can set a description. Again, description is something with its own description, a user configured description of the interface. Great. So we will do demo. And we also need to set the admin state of this interface. Well, we may skip this, but it's better to be explicit. So admin state. Now, admin state, you would just type enable. Let's see what happens. So if I type enable and try to make sure that it works, you see there's an error. Argument of type literal enable cannot be assigned to a parameter of type enumeration. Now, the reason is that admin state in our Yang is an enumeration that sets specific values that you can use. You cannot provide just a raw string here because, as I said, there is an enumeration that is expected to be here. This is very good for an automation practice because you want to know what values can you provide, and that is something that you do not have in templating. In templating, it's like raw strings. You template basically text. There is no type validation. There is nothing that can help you out there. Here, the IDE tells you that you are in the wrong. Although technically you still want to enable this, it's not the way how to do that. Instead, we need to provide this particular enumeration value that it is expected. And as you can see, the enumeration is named enumeration enum. What we need to do is we need to provide the enumeration enum here. So what I'm doing, I say SRL if enumeration enum, and here you see I have a choice of disable and enable, and both of them are available. So I can type dot enable, and that is now the error is gone. Now my admin state is of type enumeration enum, and the enable value is enabling the interface. Okay, this is sweet. So that is the interface, right? If we stop here and see what this generates back at us, we can just do print e11 object that we created, model dump JSON, the same thing that we did with OpenAPI spec in the previous video, and we can say indent equals 2, and we want to exclude onsets and defaults and every field that is not being explicitly set by us. Exclude none, exclude unset, and I will also exclude defaults. So now let's see what this gets us. So if I go to my terminal, the interfaces script, you see that I have the generated payload for my interface. There is a name that we provided, there is a description, and there is an admin state. Now you see the admin state is actually a string. That's how it is being serialized. And we provided an enum so that we are sure that this is the right type for the value. Now this is super cool. So okay, just interface and its description and its value is not fascinating. Let's try to create the subinterface and the VLAN values so that our example is more complete. And we start creating a VLAN. So first we need to set the VLAN tagging of on the parent interface. We want to enable this physical interface to be tagged. So VLAN tagging, if you look at this in the fields list of this class, the VLAN tagging has a Boolean value. So it's either true or false. Again, it's not a string. It's either true or false. So here I set it to true. That's great. And now we came to a part where we want to create a subinterface under our parent interface. So how do we do that? I know that there is a subinterface list that we need to create. But again, how would you know? You can either go back to the JSON schema, and here you can see that under the subinterface field name, you have an array of subinterface list entry, and that is how you again create subinterfaces for parent interface. If you open this up, you will see what a subinterface can have, like which fields, again, description, admin state, MTU, etc. But you also can use the Yang browser. So if I go to the Yang browser, and now I'm browsing the interface subtree, if I go down to the subinterface, you see there is a subinterface with an index as a key, and there are some fields that you can provide, like, and of course the index and then admin state, and you can see which fields you can set. Some fields are required. You see the asterisk here. That means that the index needs to be provided and it's a key of this list. But we will go back to our terminal and we'll start typing in. So our subinterface is a list. So if we go to our hints here, we will see that the subinterface is a list of subinterface list entry. So we need to create a list of SRL if subinterface list entry. That's how it's done. So now we're in the context of subinterface list entry. And what we can do here is we want to start providing the values of these interfaces. Let's say our index, that is our index, is 10. We will set the type of this subinterface to bridged. It's a string type, bridged, right? And then we will have some admin state as well. So we'll set the admin state. And here again, we will use the same enumeration for enable because it's the same enum value that a parent interface and a subinterface use. And what else? We finally go to the part where we define the interface VLAN or subinterface VLAN. Now, the VLAN is, if we go to the subinterface list entry, we see that the VLAN is a container. So it's a VLAN container type. So we can create an SRL if VLAN container. And here we just need to, again, drill deeper and provide the encapsulation field with an encapsulation value. It has its own class. Again, this is something that is might feel a bit more convoluted compared to just templating a string, but this is exactly how you deal with classes and subclasses and nesting structures. It doesn't really matter if it's Python or Go or any other stuff. It's just like the composition of things. The encapsulation lives under the VLAN, VLAN lives under the subinterface, subinterface belongs to an interface. If you want to provide all of that, you need to provide all of that. There is no way around it. And with model-driven approach, you just have less margin for error because everything is typed and you work with native language constructs instead of just raw strings. So now with encap, I will set the encapsulation to encap container. Again, I'm not even showing that it's all coming from the schema or the classes. You can definitely go here to VLAN container and see that the encap is an encap container, and you see what encap container can hold. It has either a single tagged or untagged. All that stuff is there for you, and IDE will hint you. Now, I'm creating an encap container, and in this encapsulation container, I want to set the single tagged value. And the single tagged value will be of type SRL if single tagged container. And then the last thing is VLAN ID that we set here. And the VLAN ID will be, if I just set it to 10, you see that there is an error because this value cannot be assigned to a parameter VLAN ID of type VLAN ID type because there is certain type that is expected and it's driven by the Yang model. So I will say VLAN ID type, and this type can finally accept an integer value. So now it's all good. Now I have created the fully strictly typed and modeled representation of an interface, physical interface with a subinterface, and subinterface with a VLAN ID and VLAN of subinterface of particular type bridged and a VLAN ID of 10. Now, if I go back to my terminal, I can validate that if I print this, if I execute the script, my interface payload is now way more complete. I have an interface high level fields like the description, the admin state, the name. Then I have the list of subinterfaces. And under the subinterface, I have VLAN encapsulation. And this serialization happens automatically by Pydantic. Pydantic knows how to generate the JSON payload. And with the model driven by the Yang, we can now just generate the full Yang or the full JSON payload for our model without even thinking about how to generate this. We don't template, we don't do, this peculiar templating with spaces and tabs. It's all gone. We fully working with Pythonic constructs, how I think developers would definitely want to work with network configuration rather than just templating. All right, so now we have created this stuff and it's all good. And we validated that it works and we can generate the JSON payload. But this is just like probably the most important part, but the example is incomplete. We now need to ensure that we can use this payload to actually ship configuration to the device so that we can see that we can configure an interface. So I will just remove the print here. So now we want to make sure that we can use this payload that we just modeled in pure Pythonic constructs, and we can send it to our device. So I have created a class here of a Linux client, which is just basically an HTTP client, because on SR Linux we have a JSON RPC server, and we can use kind of REST interface, but not REST. It's just like pure JSON RPC. We can push different payloads there. So I will reuse what I have created in my client py file, and this is gonna be the SRL client class that I will use. So now let me just import this stuff, client import action and SRL client. So now this should be all working. What this is, again, to reiterate, is simple HTTP client. There is no magic there, but what is really interesting here is that I add a command to this client that populates the payload that we sent with JSON RPC, and I set the path that I want to a payload to be created on. So I use the update operation. So I want to update whatever sits under the interface name Ethernet 11. And as the value, as you can see here, I pass my object. I don't pass the raw string, I pass an object. And then what will happen in the add command method is I will just dump this model to a JSON payload, and this JSON payload will be sent through JSON RPC to a device. So again, this is something that is quite unusual to regular gene templating, because we pass the model. The model is being serialized by Pydantic to JSON, and then this model is applied through this serialization to a device by using the JSON RPC interface. So let's see how it works. Now let's connect to the SR Linux node, and we will install a watch over the interface Ethernet 11. And as you can see, there is nothing reported back because we do not have the Ethernet 11 interface just yet. We have a bare SR Linux containers created by ContainerLab. There is no Ethernet 11 interface, it's just a single node container. So now we will try and use our interface script, which now should take the model that we have created with Pydantify, and it will serialize that and use the JSON RPC client to send the serialized blob to our interface. So let's run it. Now, as you can see, the interface has been successfully created with a subinterface and the VLAN ID, and it was like instantaneous. Well, it's nothing, it's just a simple configuration action. But as you can see here, we sent an HTTP request to a JSON RPC server in SR Linux, and that is how we created this interface. But the way we modeled this interface is absolutely totally different to a traditional templating based approach. And probably you saw how easy it is to create those models because it's documented. You have type hints from the IDE, and you have different browsers that we at Nokia Soul Linux provide to you, so that you have an easy way to understand the structure of your commands and how they are related one to another. Now, this was a very simple example. Let's kind of complicate it a little bit so that you see how much more benefit can you get from this approach. So I'm back at my IDE. So I want to create another file. Let's call it VLANs. So now I want to create multiple VLANs to my Linux container. And instead of typing this thing, let me just copy paste what I have. So I just copy pasted a different example. But now what we will do here is that instead of creating just one VLAN, let's see what we're doing. We are creating the E11 interface, but then under the subinterface list, instead of just manually typing at body of the subinterface, we use a function create VLANs, and we provide 3 different VLANs. Like I want to create VLANs 100, 200, 300, and I want this to be replaced. You see the operation replace here. I want this to be replaced under my interface Ethernet 11. So in the previous example, we created an Ethernet 11 interface with VLAN 10. Now I want to create 3 VLANs altogether with IDs 100, 200, 300, and I want this to be replaced. Now, what this function does, create VLANs, as you can see, it does exactly the same, but instead of doing this templating with ranges and these loops that get out of control, we use a proper for loop in Python land. And in this for loop, I can use different types, type annotations, so that I always know that I'm creating objects of a certain class and they are properly typed. And all of these types, I don't have to create them by hand. They come from the Pydantic for Linux project, thanks to Pydantify. So now here it's kind of the same stuff. We just append VLANs to an empty list. And after the 3 VLANs are processed, we return this list, and this list is being used in the subinterface field of interface list entry. So now I have this VLANs py file. Let's try to run it. So I'm back at my terminal. We have a single VLAN created. You see the watch is still working. We are refreshing the interface 1.1 configuration every 2 seconds. So I will now run the Python VLANs script. And the expectation is that instead of having this subinterface 10 with VLAN 10, I should have 3 subinterfaces, 100, 200, 300. Let's see. Okay, here we are. The subinterface 10 is gone. We have 3 subinterfaces with IDs matching the subinterface index. They have been created very, very fast, but the speed is not the matter here. The matter is in how we generated this stuff. And we generated it with pure Python constructs, with for ranges, with type annotations, with variables. So it's definitely much more easier and safer to use these constructs instead of text-based templating. So here it is. The summary is that with Pydantic for Linux project, we wanted to make sure that you can get kind of more or less full model-driven network automation based on Yang. Now, when I say more or less, there is still some gaps in Pydantify, and we are still working on ironing out some smallish errors that might be there in the models. But the gap that we initially had has been practically covered. Again, thanks to Dan and Urs. It was a big effort to forklift in such a short amount of time. And I encourage you, if you're working with SO Linux or if you are interested in model-driven approach, give this project a try. If you don't work with SO Linux, just have a look at the Pydantify project. Try to see if you can apply it to your models, to the vendors that you use. And I hope that you will be able to contribute with us and see how we can steer the project forward. Thanks, everyone. See you next time.